What is the difference between a manual valve seat machine like our SERDI 4.5 that we bought a little bit over 3 years ago and a CNC valve seat machine like the SERDI Profile that is the newest machine that SERDI has on the market? Well, some of the folks over at SERDI actually in France have seen some of our videos and they love them so much that they actually reached out to me a few months back and invited me out to their United States location in North Carolina to kind of get some training on the SERDI Profile and do some content on it. And the goal is going to be to educate you guys about this new machine and kind of make some comparisons between a manual form tool valve seat machine and a CNC single point valve seat machine. There's also going to be a more technical video on the SERDI Profile that will be linked in the description for those of you who want to see it in more detail. But hopefully this video will be easy to digest and kind of answer the question of what's the difference between a CNC seat machine and a manual seat machine. So with that said, let's get into it. I'm actually going to fly out to North Carolina and just showcase the differences here and show off the capabilities of this amazing new machine that SERDI has on the market. I'm actually here at SERDI USA. I have Renaud with me from France, so hi. You want to kind of introduce yourself?
So Renaud, working for SERDI since more than a decade now. So I came from France as well to show you how the machine is working, what are the basics. Obviously, cut some seats and
yeah. So you're an expert on this machine, right?
Kind of.
Kind of. This thing, you can program in any seat profile that you want, basically.
Yeah, that's it.
And you use the same cutting insert on every single one. You know, I've got a box in my toolbox there next to the SERDI, probably 100 different cutting inserts that I have to get different profiles, different seat widths, different seat angles.
Actually, we've got a bit more than one insert because insert material depends on what you want to machine. Most commonly, we use CBN cutting bits because it allows to make a good job on really hard valve seats. And we have two different sizes of cutting bits. So like with 5 or 6 different cutting bits, you can machine a lot of different things.
Yeah.
On this machine, as you've got a combination of CNC axis, vertical and horizontal, like you can create any segment and radius you want, so you don't need that many cutting bits.
Yeah.
So the machine owns 3 different axes that are all synchronized when machining. We've got U, Z, and C. I just selected U axis, and you see, like this is my carriage. So this is my horizontal axis on which I will assemble a tool order.
So that's going to move the cutting bit out in diameter.
Yes, that's out or in, according to
whichever
the
direction.
Strategy. Yeah. Then this will be used in combination with the Z axis, which is the vertical axis like that. So that's basically the combination of those 2 axes which allows you to create the, I don't know if we speak about the 3 angles profile like 30, 45, 60, everything will be done with a combination of U and Z axis.
Yep.
And last axis we've got is the C axis, which is rotation of the tool. The main benefit of this axis being numerically controlled is that you program the machine with a linear speed. Like you don't program spindle speed. Like for example in the 4.5, you know, you got the speed potentiometer. There you will just program a linear speed in feet per minute or meters per minute.
Yep.
Which allows the tool to be always at the same cutting speed on whatever the diameter of the valve seats.
It gives you, I guess, consistent chip load probably on the cutter.
That's it. If I spin this, you see this device is pretty big because when I move my carriage, you see here, like inside, we've got a counterweight which balance the weight of my tool here. This allows to have a mass center always located in the rotation axis and avoids shattering or vibrations during machining.
Right. Right now we've got an LS head that we're going to do some cutting on.
We'll be reusing this one and like show you the process of basically what we call doing a recut, meaning your seats are already cut and you just want to refresh them of like very small amounts.
Kind of the same thing as on every seat and guide machine. You want to be level when you do this.
Yeah, so you can see here I inserted my pilot, the best pilot which could fit with those guides. So in that case, that's 7.995 millimeters.
Yep.
Just inserted the level on it. And what I want to do is like align my bubble into the circle of the level like this. You still have a bit of tolerance because the sphere, the air cushions will compensate the small defects you have.
Yep.
The main difference with our standard SERDI machine is like we've got like a hydraulic collet inside, so I just insert my pilot right here, find this little screw, and when I'm clamping this screw, it compresses oil inside the collet, and all the oil is coming, forcing into the center, so it helps to have a good concentricity of the pilot comparing to its holder.
In a standard tool holder, I mean, there's always a small amount of clearance there between the pilot, and if you just have a set screw that's pushing against it,
you will have slightly bent on the pilot tip on this side, and this has a big influence on concentricity later on. So I need to tell the machine which diameter is currently the cutting tip. So that will be 1.7795.
Okay.
And I will enter this value of 1.7795 inch. Okay. Once we've done this, you see it updated this position, it's its current position, and when I will move it, like the diameter is displayed live on the Siemens software.
Okay. At this point, we're going to pretend like this is a head that has been run before, and we're going to go in and you just want to take the smallest amount of material off of these seats to where they clean up and they'll seal again and they're concentric. So kind of walk us through what the process would be and how we teach the machine what the seat profile is.
Yeah, like if you already know the cutting bits you are using a standard machine, you just can copy the profile and insert it into the machine. If you have no really idea, you can use a caliper and guess about the angles. Obviously use valve angle as a reference, like 30, 45 according to what you're doing, and then after make a guess on throat angle or upper angles, etc.
Okay.
In my case, I already know my program. You see on this column here, you've got add line, add radius, so it's basically a combination of different elements that will create your machine profile. So that will be a 0.07 inch, 90 degrees, like that. Then I would add a 30 degree, 0.031 inch, and 30 degree. Then the machine starts to draw the profile on the screen here. Then I would add my seat segment, which is like 0.0845 degrees. And at that point, I need to tell the machine, this is my seat segment. So you see my seat segment is becoming red. So later on, when I will input the diameter, it will take this as the reference.
Okay.
Then I will just finish it by my 60 degrees, which is 0.2 inches, 60. Okay. And like in 4 segments, I draw my profile. So it's pretty easy, you know, but you can combine as many elements you want. Could be line, could be radius. You can do venturi shapes as well, positive shapes into the material. It all depends on what you want to do with the machine. If you have a flow bench, you can machine one profile, then test it on your flow bench, modify it. I took as a reference my 45 degrees, so I need to put this segment, this point here at the proper diameter. In my case, I measured earlier and I found like 2.165 inch is doing good. The machine allows 3 different machining strategies, which are longitudinal, contour parallel, and recut. In our case, as we want to remove as few material as possible, we will use recut machining strategy. I will program a number of roughing passes, which you can set up from 0 to 3. By safety, at first always put 3 roughing passes. This table here, like you've got your speed cutting, which is currently 450 feet per minute. FR is for my feed rate, so that would be 4,000 inches per revolution. Meaning that on 1 revolution, the tool is moving of 4,000 on my profile.
Okay.
And then I've got my depth of cut, which is 4,000 between two roughing pass. So that will make 3 roughing pass and 1 finishing pass, which has smaller feed rate and smaller depth of cut for better surface finish. Important point is the float time as well. Like when you use your standard SERDI machine, you know you will open your 2 air cushions, spherical and plain air cushions. Mm-hmm. And you will look at the 2 arrows if they are still or not before clamping your system before machining. On this machine, you program a time, and when you know the machine is centering, you have to make sure at first that it's still before clamping.
Yep.
Usually, I set the time at first on large pilot like this, we can use 8 seconds, maybe even less. I think 6 seconds will be fine. Once I've set up my machining data, I will need to teach the machine where is my seat on the vertical axis. So first thing to do will be like set up my probe. You can see the probe gauge is moving according to the position of the probe, so I have to reach the center of my gauge more or less like that. Then I hit probe, start. The machine, the spindle rises a little bit. Air cushions are opened. And centering is made. And next point would be to make the touch off. So touch off means just touching the valve seat with the cutting bit. So in that case, I will be using the controls of the machine. So I will rise up a little bit like that. Only my spindle is moving. I will expand my U-axis, and as you can see on the CNC screen, I have like the position that the tip will reach when I will touch my seat. So I can, as I already know my profile, I will just touch between the 30 and the 45 in this area more or less. Then I slightly go down by high until I get close enough from the valve seat. Something like that. And then I press cycle start. This will run my spindle, okay? And then I slightly go down until I hear my cutting bit touching my valve seat. Just hear the noise. I press input. Then goes down, and the probe measures the distance between my point where I touched and the deck.
Okay.
So right now, as the deck is my reference, my machine profile will always be made at this point. Another parameter to adjust, which is the depth adjustments, because if I let my Z offset to 0, this means the machine profile will be made at the same vertical position of where I touched, but I would like to I will just remove as few as material as possible, and I still can adjust this distance later on if I want. You see, I remove very few materials, so I put 3 roughing pass, and I will cut air for 3 pass, obviously, because I remove very few material.
Okay.
I can save my program.
So you can save, I mean,
Yeah,
as
you
many
see,
programs as
we already have a lot on this machine, so I can run simulation of my program. That's it.
Okay.
Then I press execute. Execute will load my program into the CNC controller, and I'm ready to machine. So when I press execute, machine moves to auto mode. Then I just need to press cycle start. So it's currently centering for 6 seconds. The probe is measuring and machining will start. So as I said, I think I will cut air for 2 or 3 passes.
And it cuts from top to bottom.
Yeah, you can only program finishing in the opposite direction.
Okay.
There you go.
Okay.
And the reason we didn't cut the bottom is because I think yesterday we cut a 65 instead of a 60.
We may have.
Yeah.
So in that case, I mean, this is a situation that a customer may very well run into, is where they guessed that was a little bit shallower angle, but it's actually a little bit steeper. So what we got here is it cut the top and it cut the seating, the seat angle there, but it didn't cut the bottom angle.
In that case, I will just come back into my program, change my bottom angle to 65. That's it. And back, and I will just change, instead of 3 roughing pass, I will use only 1, because it's enough. And maybe go slightly deeper, like add 1/1000 of an inch, so I could recut my wall profile on the right. Auto, second starts. Centering.
So that's a great example of how quick it is to change, one profile there, or one part of the profile rather. Amazing.
And then it's clean. Another thing, like once you finished your cut, the machine asks you, do you want to go deeper in case, like the thing which happens on use head, like you always, so you can have like a part of the seat which is clean, and then some parts are like still rusty, so you still need to be to go slightly deeper. So in that case, if we want to go just 1,000, we can even, set a smaller distance. Like we are currently at 2,000s, minus 2,000s, and we can maybe try minus 0.0025. Okay, and run it.
So you're going 5/10.
Yeah.
And somebody may argue with me, but there's no way you're doing that on any form tool machine.
I don't think so.
I don't think you can take.
Yeah, it's hard to reach.
It's hard to take 1,000th or even a couple thousandths at once.
I will save this value, and once this is saved, I can do all my other exhausts at the same.
All your other intake at the same depth.
Intakes at the same depth. Sorry.
And normally there's chip guards here.
Yeah,
so
but we removed it for commodity purpose of the video.
I told him he had to take them off if he wanted good video, so here we are.
For the sake of making a comparison to the form tool machine, I went ahead and set up a cutter on an LS head, which I basically do by eyeballing a cutter profile that matches and manually adjusting the diameter out to match. At that point, I can go ahead and cut the seat. If I want to continue the cut a bit deeper, I can touch the cutter to the seat and either zero the DRO on the machine, or set up an indicator at 0 on the deck similar to the probe on the SERDI profile. Because I was attempting to take such a light cut, I didn't have enough pressure on the tool, resulting in very slight chatter. So I continued my cut with a continuous spindle speed variation feature on, which broke the chatter, but we ended up about 3 thousandths total deeper. 99% of the time, 3 thousandths isn't going to be enough to make a difference in the end result, but it just speaks to the ease of precision that the new SERDI Profile provides compared with a form tool machine.
We just wanted to do a check of our runout on that seat that we just cut, and we got the runout gauge here. Show us kind of how that works. And
so with our Renault gauge, like you've got to spin it on the pilot. Pilot is fixed, doesn't move relatively to the valve guide, and we just rotate the device on one rotation, and we just read the runout. So on this one, we've got 0.01 millimeter runout, almost,
which is about 4/10 thousandths of an inch.
So really small. The machine does a good job, but the really key elements when you are doing that kind of things, you want some clean valve guides with really clean pilots. Everything must be turning without runouts. So when it comes to achieve this level, like there is a lot of work before the valve seat machine.
Yeah, I mean, I always talk in my videos that the valve guide is really the foundation of the valve job.
Yeah. I believe this to be true on all valve seat machines, and as a comparison, with a properly sized guide, properly selected tooling, and some operator finesse, a form tool machine like the SERDI 4.5 in my shop is capable of sub 1,000th runout seats as well.
Now, just as an example of some of the capabilities of what is possible with the single point cutter, we decided to go in and modify the program here so that it'll cut a little bit of the aluminum here, and almost like if you wanted to kind of de-shroud the valve a little bit and make this kind of upper cut extend into basically the chamber material there. On a form tool machine, you would either have to have a cutter that already has a profile that extends that far out, or maybe you would have to come back with a second tool basically to make that cut. But you just really quickly went in here and kind of figured out what the diameter was there.
Like just basically I added one radius to my 30 degrees here and a large vertical line, so that will be my aluminum, let's say.
Yep.
I eyeballed it, by putting the cutting tip close to the aluminum, then made 1 or 2 trials until I reached the shape I wanted.
Yep.
So now that this is done, run into my next valve guide.
And you can hear and see when it's up higher, the diameter is larger, so the spindle is running about 700 RPM.
Yep. So it starts to create the wall of the vertical line, then the 30.
And now we're speeding up, 870 RPM, 900 RPM. Is that the pilot, kind of?
Yeah, pilot is. I should have put more oil into some oil in the pilot.
This is the With one cutter, you're transitioning from, your upper cut here, putting a little radius in it, our 30 degree into our 45, and then 65 bottom angle there. And man, it's so nice. I can come up with that same profile on mine, but
It will require more time and different cutting bits to achieve this. Yeah.
Because even if I had one cutting bit, by the time you're, cutting that much area with the face of the cutting bit, it's going to be such a big load on the machine. It's going to be hard to get good results. So we went through and we cut all of the intake on this head. Yep. You go through the setup process, get your first depth, and it's real quick and easy to run through and cut all of them to be exactly the same. Then let's say you want to go over and do your exhaust side.
Yeah. So I cheated a little bit because my program was already made from yesterday. So I just had to store select my program, load it into the machine, and then I'm ready to go. I just adjusted the depth to machine a bit deeper than yesterday.
Okay. Same bit, same tool holder, just different program on the machine.
Same range. I didn't modify the position of the tool holder, so.
Okay.
Can see that you didn't see, but Spindle was going way faster because I'm using the same linear speed that I had on the intake, but as the exhaust is way smaller, Spindle is running like 1,400 RPMs.
Yeah.
Once again, I want to reiterate this difference. Obviously, your exhaust seat and intake seat are a different diameter, but they also often have a different seat profile, and on a form tool machine, that requires changing your cutting insert, as well as making a manual adjustment to the diameter of your tool.
We've kind of gone through the scenario of retouching seats if they've already been cut, but there's also the scenario of putting new seat inserts in, kind of a blank slate to start with. So like these two exhausts that we have here that have never been cut before.
Main difference compared to earlier is that basically, instead of starting by my profile description, in that case, I will describe my material. Meaning that I will accurately draw my valve seat, how it is on the cylinder head with the same dimensions. And you see the machine draws a section of the seat, of my bank seat. And right now I'm good to go, and I can start create my machine profile that I already draw as well. Okay, and now I will adjust all of this, offset it onto my seat, and I will offset it a little bit. You see, I will add a depth adjust. So if I shift down on my profile, if my profile is shifting down according to my valve seat. And then I will need to check my machine data. So in that case, I will not use recut strategies as I've done earlier. I will need to use either longitudinal or contour parallel. Longitudinal will make all the roughing pass vertical. That's what you can see in green here. And then my finishing will follow my profile here. Or otherwise, I can use contour parallel, all my roughing is following my contour. Everything will be cut in that direction, parallel to my contour, and my finishing will be following this line here, blue, red, blue.
Yep.
But usually, contour parallel is a bit more efficient.
Okay.
Okay, and right now I need to teach the machine.
So just like earlier, now you're...
I'm adjusting my probe.
Okay.
I can run my touch off. This time, the cutting bits will be touching the top of my seat. So it doesn't matter where I touch, it just need a value of this surface. Just touched it, press input. Can save, I will save test blank. Can run my simulation.
So yeah, you can see you just have a little sliver of the 30 there on the seat still. And then the what is it, 80, is it a 60 thousandths wide, 45?
Yep.
And then our radius down into the bottom. And I mean, it just cuts beautifully. We're putting a head up here to showcase cutting counterbores for if you were going to install new seats.
So for example, in my program right now, I defined, so you see in yellow is my counterboring, and my blue line here will be my new counterboring after machining. And I set up a value for which we call Umax, so which will be my maximum diameter which will be machined, so 1.953 inch. And so we'll cut that and then measure with a micrometer to see if it comes in
See where we're
what we
at.
programmed. Okay, so we machined the first counterbore. So yeah, right now I will straight move to my second counterbore.
And since the probe references the deck, you know, the surface of the head there, you didn't have to, even though the head is tilted funny, you don't have to re-zero. Or
Yeah, whatever, because the probe will, once the probe touches the head, the gantry will block.
Right.
Will clamp. So that's 49.65 here. As this tool is measuring in metric,
Sure.
so like I'm 49.65 I would say here. And on this one, first one I made, you see 49.65, 66. Yeah, I'm slightly too big compared to what I programmed. But at least you can see the result is the same on
Yeah,
both
the same
sides. So
between the two.
what, like, reason is, you know, there is still a bit of, when you measure, there's small imprecision with the SERDI digital, and we still have an option to the machine where we can, you know, compensate, we call it tool wear, like if you notice you are measuring too high, this is what we've got here, well, you just need to compensate. So I was 2 thousandths too large.
Okay.
So I compensate with 2,000 smaller,
Okay.
like that. Tip radius, okay.
So yeah, that was like your first cut. What you measured versus what you told the machine was about 2 thousandths. It cut about 2 thousandths bigger.
Yeah,
So
so
now you're compensating by telling the machine that.
On my next cut, which will be bigger, it will be compensated by those 2 thousandths later on. So I just need to modify my profile. Profile description, seat diameter, and let's put 1. So 1 point.
So it's really quick to change the size.
Yeah.
I mean, like on my machine, I usually would sneak up on it. You know, I'd start smaller, make a cut, measure, make sure that it's cutting. I mean, basically do the same thing you did here. Make sure that we're cutting where I want it to so that I don't miss that mark. Because
on your final cut.
Yeah.
You always do like usually a smaller cut than what you need, you adjust, and then the machine does the rest once you adjusted your diameter.
But as far as the programming to change the diameter, it's really quick. It's not, you don't have to redraw the entire thing.
No, you just need to set up it properly and 49.68 right here. And the other one, exactly the same measurement by 0.01 millimeters.
Yeah, that's amazing.
Now we are spot on because 1.956, 1.956 is 49.68.
Okay.
And now you can read 49, that would be 60, 65, and 68 is here.
As far as counterbores go, the process is the same but faster on the SERDI Profile compared to using adjustable counterbore cutters on the SERDI 4.5. But again, the larger benefit with the SERDI Profile is that one tool hits a wide range of counterbores as opposed to having a drawer full of fixed diameter counterbore cutters like I do.
All right, so I've spent kind of 3 days with you learning about this machine and spent the whole day today making videos about it and kind of trying to showcase all of the abilities that it has and what a great job it does. I guess thank you first of all for your time and thank you for inviting me out. It's been, I've really enjoyed it. It's been fun. I'm excited to go home and make this content and get it out for people. And this video will go out before PRI 2023.
Yep.
SERDI will be out there with the Profile as well as I'm assuming some of their other machines and equipment.
Standard machines as well, yeah.
Okay, so be sure if you're interested, stop by, take a look at the machine. You'll be able to watch a demo of how it works and how it's running. Honestly, I'm dreaming of having this machine. Someday, I got to go home and work really hard because I got to get one of these in my shop. So I think it's been really fun and a really cool new machine.
Yeah, thank you for your time.
Sure.
And,
thanks for coming out.
Yeah, thanks.